Hello guys, and welcome to the homework review. We're going to be going over questions 67 through 75. We are going to do all the questions here. If you don't want to look at all the questions, go ahead and look in the description. There will be timestamps to each question. You can jump around as appropriate. So let's go ahead and get started. So for every single one of these, we're going to be creating a graph. Now, in order to make this graph, we're going to need to know three things. We're going to need to know the zeros, the end behavior, and the multiplicity. The zeros are where our graph intercepts the x-axis. The end behavior means what does our graph look like when it goes to negative infinity and positive infinity, aka is it going up or down, or up or down. And multiplicity refers to the degree on your zeros. Essentially, multiplicity is going to dictate what your graph looks like around the zeros. Okay, so these are the three things we're going to need to know, and we're going to have to go through and do all that for each one of these. Now note, you can use a calculator with this, and it's actually going to almost do the entire question for you if you really want to think of it like that. However, you should know how to do this without a calculator, and because of that, we're actually going to go ahead and do this without a calculator. If you want to use a calculator, go ahead and use so, and check it as you go. That is my cat, I'm sorry. She's making a statement. Okay. Thank you. Alright, so first question is f of x equals x cubed minus 9x. Okay, so again, we're going to do this without a calculator, so we want to look at this, and we want to try and factor this as much as possible. The reason why is when we factor this, this is going to give us our multiplicity and our zeros. So let's go ahead and start factoring it. What is the factoring that we can do to this? Remember, factoring is a complex skill. There's many different kinds of factoring you can do within a question. Right? So we're going to have to be very clever and pick out the kinds of factoring that we can do. One of the most simple forms is the greatest common factor, or pulling out a common factor of each term. If you look at these, you're going to notice that both of these have x's. So we can go ahead and pull out an x. That's going to leave us with x squared minus 9. Okay? Beautiful. Now there is one more step we can do, and so for you clever people out there, right, what do you notice about this? Right, we can notice that this is a perfect square, and 9 is also a perfect square. That being said, they're both perfect squares. There's a difference between. We can use our difference of perfect squares formula. If you're unsure of it, go ahead and look it up. So using our difference of perfect squares formula, that's going to turn into x plus 3 and x minus 3. Okay, again, if that was a really big jump for you, go ahead, look it up. Pause the video, search difference of perfect squares. Okay, so we can go ahead and factor that. Side note, if you didn't remember to do that, remember you could also go ahead and do the magic method, right, or factor by grouping. Right, a is equal to 1, we don't have a b, and c is equal to negative 9. So we would just look for, since a is equal to positive 1, factors of c, which would be negative 9, that are going to add to b. Notice how b is equal to 0 here. Okay, so what would those two factors of negative 9 that add to 0 be? Well, nothing more than negative 3 and positive 3. And notice how that's going to perfectly agree with the difference of perfect squares shortcut that we took right there. Okay, so we factor this, and we get it to this point. This is good. We've actually already answered multiplicity, because multiplicity refers to what degree is on each of our factors. So when we go ahead and look at this, we only see, well, we see no powers technically, right? But we should know that that means each is a power of 1. Right, so each has a multiplicity of 1, which means that around each of these zeros, it should look something like a first power, aka a straight line. Right? So at each zero, it should look something kind of like a straight line, because it has a multiplicity of 1. Now, what about the zeros? Right? So what are the zeros going to be? Well, the zeros are just going to be what brings each factor to 0. Okay, so what number is going to bring each factor to 0? Well, we're going to have x equals 0, right? If that was 0, that would bring the whole thing to 0. If this was negative 3, that would be a 0. And if this was 3, that would also be a 0. Right? Each of these numbers would bring their corresponding factors to 0. So we found the zeros. We know the multiplicity of each 0, right? They correspond to the factors. And now we're going to look at the end behavior. There's a few ways to do end behavior. The first way is to look at the highest power of your x and then make your graph look something kind of like that. Or you can go ahead and plug in infinity and negative infinity. That's actually the more foolproof way of doing it, and that's what we're going to do here. So we're going to go ahead and define the end behavior. Right? The end behavior is going to be f of negative infinity. Sorry, I know it's a little bit weird to start with negative infinity, but it doesn't really matter. F of negative infinity, we're going to plug negative infinity into just x cubed. Why just x cubed? Because it's the biggest power, and it's going to be the power that matters the most at very large numbers. So we're going to have negative infinity cubed, which is going to equal negative infinity times negative infinity times negative infinity. Okay? And now, don't let this intimidate you, right? Infinity times infinity is just infinity. So all these infinities are going to become one infinity, and then we have three negative signs there, right? Negative times a negative times a negative, that's going to be negative. So what this tells us is that the end behavior at negative infinity, right, to the very far left, is going to be negative infinity, meaning it's going down. So to the left, it goes down. Let's go ahead and start making a graph to see what this looks like while we're making it, while we're finding it. Okay, so I'm going to go ahead and put my zeros. There's a 0 at 0, negative 3, and positive 3. Okay. Now, before you go ahead and draw your graph, right, before you go ahead and connect these dots, first off, we're going to need to know the multiplicity, but we're also going to need to know the end behavior, right? You don't know if this goes up or down until you find out the end behavior, and that's why we need to know this. So we go ahead, we first found the end behavior at negative infinity, and then, right, so it's going to be going downwards at negative infinity. So right here, this will go downwards. Okay, and likewise, we can do the same for infinity to see what's going to happen when it goes to the right very far. And that's going to be infinity cubed, right, which is just infinity times infinity times infinity, which is equal to infinity. All of them are positive, so it's going to stay positive. So when this goes to infinity on the right, it's going to go up to infinity. So right here, it should look something like this. Beautiful, right? Now let's go ahead and use our multiplicity to figure out how we should connect these, right? Because there's many different ways we could try and connect these, and it depends on what the multiplicity is. So we have a multiplicity of 1 for each one. That means, roughly speaking, there should be about a straight line going through each 0. So we'll draw a straight line through there, straight line through there. You can see how it would have to curve like that, and then curve back around to make that straight line. And that is our graph. Right, that is our graph with all three of those things. Okay, so that is 67. Sorry, cat. Let's go ahead and go on to 69. And we'll label that one too. 67. Okay. So 69 is going to be the equation 1/4 t squared minus 2t plus 15. Okay, that's our function. Now when we look at this, sorry, that's a very poorly written f of x, if you can tell what that is. F of x equals that, right? And it's also right up there. Now we look at this and we see a 1/4 right there. It's actually not going to matter, right? This is just multiplying this, and it has no variable in it. So ultimately, it's not going to affect what our zeros are. And notice the same up here, we could have multiplied this whole thing by any number we wanted, right? Put maybe like times 9 on the outside. And it wouldn't have changed our zeros, it wouldn't have changed our multiplicity. All it would have changed is the stretch or the shrink of our graph. So don't even worry about this 1/4, it's outside of here. We're not going to look at it. And we're just going to look at what's inside here because this is going to have our zeros and also our multiplicity, along with end behavior. So let's go ahead. We're going to find the zeros of this. So to find the zeros of it, we're going to start by factoring this. So again, we're not going to look at the 1/4. We're just going to look at what's inside here. We see a trinomial. We can go ahead and try a factor by grouping. So again, A is equal to 1, so that's very nice. We can take our shortcut. So factors of C that add to B. Right? C is going to be 15, and B is going to be equal to negative 2. Right? So what are the factors of 15 that add to negative 2? Well, that's going to be negative 5 and positive 3. Okay? A is equal to 1, so we can go ahead and skip the by grouping part and just write our factors right here. So T minus 5 and T plus 3. And we have to bring down that 1/4 as well. It didn't go anywhere, but we weren't working on it. We were just working inside of here. Alright, so these are our factors. We can look at them and we can tell they're going to have a multiplicity of 1 because they all have a power of 1. And the zeros that would go with these are going to be positive 5, right? X equals positive 5, and also x equals negative 3. Okay, those will be our zeros. And last but not least, let's go ahead and find our end behavior. Now, when you're doing these, right, if you want to actually, well, I was going to say you can start with the end behavior first and graph that and use that to start graphing the other things, but the thing is, you really need all this information if you want to start making your graph and you want to start sketching it. So don't start sketching it until you get all this information. Okay, so our end behavior is going to be plugging in negative infinity and positive infinity. So if we plug in negative infinity into here, right, and we can look up here, right, so f of negative infinity is going to equal t squared, right? And we're going to plug it into t squared, but we also want to attach the 1/4 because the 1/4 is multiplying t, right? 1/4 multiplies t, so we want to make sure that that doesn't mess with the sign when we plug this in. So let's go ahead. We're going to have 1/4 times negative infinity squared, right? We just plug it in, negative infinity to t squared. Negative infinity squared, well, infinity times infinity is going to be infinity. And a negative times a negative right there is going to turn to positive. 1/4 times positive infinity, well, that's still just an infinity. So this is equal to positive infinity, so that means it's going to go upwards when it is going left, right? Negative infinity is going to be left, and then positive infinity over here means upwards. Likewise, let's do the same with positive infinity. Now we're going to the right, right? Very large numbers are to the right. 1/4 and infinity squared, just plugging in our infinity. And we are going to have that equal to positive infinity again, right? Infinity times infinity is still infinity, times 1/4 will still be infinity. So what does this tell us? This tells us that as we go to the right, remember this is where x is, so this is going right or left. Positive infinity is going to the right. Negative infinity is going to the left. So as we go to the right, we are going upwards to infinity. As we are going to the left, we are going upwards to infinity. So our graph should look something kind of like a parabola. And in this case, it's actually going to be a parabola. Okay? Our parabola has a 0 of 5, and it has a 0 of negative 3. As far as the end behavior goes, what's it going to look like? Well, they're both going upwards. So we'll draw our arrows going upwards. And then we will go ahead and connect these. And again, notice how your line should be relatively straight going through here because we have a multiplicity of 1. Right? If this was a multiplicity of 2, then it would look like a parabola there, right? It would kind of come and touch and bounce. But as you can see, that kind of wouldn't make sense here. Your line would be discontinuous if you had something like that. Or you would have another 0 if that was the case. But here it's pretty simple. All multiplicities of 1. Both of our end behaviors are going upwards. And our zeros are right there. So there's our graph. Okay, let's look at 71. 71 is going to be f of x cubed minus 3x squared. Okay, again, we want to go ahead and factor this. That's the key to finding our zeros, our multiplicity, and our end behavior later. So Let's go ahead and factor this. So we're going to take out the greatest common factor. We can notice that the greatest common factor is x squared. So x squared, and then we're left with x minus 3 after factoring. And that's good. That's really good, because notice, can we factor x minus 3 anymore? Well, no, we can't, because there's no power of x. And x squared, well, that's already as factors as it gets. So this is completely factored, and that was actually very easy, right? So this is completely factored. Let's go ahead and say what our zeros are going to be. Okay, our zeros are going to be x equals 0, right, corresponding to that one. And our other 0 is going to be x equals 3, corresponding to that one. Now, here's where we get a change of pace for multiplicity. What is the multiplicity on x minus 3? Well, that one is 1. But what is the multiplicity on x squared? So what does that tell us? We should see something kind of like a parabola at x equals 0. Okay? We'll even make us a little column right here for it. Right, multiplicity 2 and multiplicity 1. Okay, now let's go ahead and look at end behavior. Right, end behavior is going to be plugging in infinity and plugging in negative infinity. So let's go ahead. We're going to plug in infinity and negative infinity, and maybe you've done this so much that you already know what it's going to be. If so, good for you. Right? Infinity cubed, we're plugging it into x cubed because it's our highest power. It's the only thing that matters at very large values. So infinity cubed, well, that's just going to be infinity. Right? Because infinity times infinity is just infinity. Likewise, let's do the same with negative infinity. And we're going to have a situation where infinity cubed is still just going to be infinity, but this negative cubed is going to give us a negative. So it'll be equal to negative infinity. So what does that say? That means as it goes right, it goes up, and as it goes left, it goes down. All right, so let's go ahead and make our graph for this. Can we squeeze it in here? I bet we can. If we are very careful, I think we can squeeze it in here. So we'll go ahead and draw it right like that. We have zeros of 3 and 0. Oh, this cat is just determined on making a guest appearance. Luna, stop. And we have a 0 of 3. Okay. Now, what is the end behavior? Well, the end behavior is going to be, as we see, negative infinity, right? That's going to be left and down. So as we go to the left, it's going to go down. And as we go to the right, it's going to go up. So this one will go up. And now here's the tricky part, right? How do these two connect? You may be inclined to draw a straight line and then try and loop it back, but you're going to see it's not going to quite work, and there's going to need to be a parabola in here. How do we know where the parabola will be? Well, that's where we look at our multiplicity. We see a square on the factor of x, which corresponds to a 0 of 0. So right here, we're going to see a little mini parabola. And then it connects with the rest of our graph. And so that's what our equation looks like. Okay. Next one. So we are looking at 73. Okay, so 73 is going to be f of x equals 3x cubed minus 15x squared plus 18x, okay? So you know the deal. We're looking for our zeros, our multiplicity, and our end behavior. So let's go ahead and start seeing what kind of factoring we can do to this. We can factor out a greatest common factor. So we are going to have x, which can be factored out. And can 3 divide all these things? Can we pull out 3 out of all of these? Well, let's go ahead and look at that. 3 would evenly divide 15. It would also evenly divide 18, right? 3 times 6 is 18. So let's also factor out a 3. So we'll factor out a 3. And that's going to leave us with x squared negative 5x and plus 6. Okay, So we factor it out to there. Is there any more factoring we can do? Absolutely. We see x squared right there with some other terms next to it. That should be an indicator that we can factor this. And what can we use to factor it? We can use factor by grouping. So let's go ahead and use factor by grouping. Notice how a is equal to 1, which is very nice because that means we can take our shortcut. So factors of c, which is 6, that add to b, which is negative 5. Factors of 6 that add to negative 5, well, you might have to think about it a little bit, but it would be negative 2 and negative 3. So then we can go ahead and write our factors. So this will be x minus 2 and x minus 3. And don't forget to bring down the 3x, which was in front. We didn't touch it. We were working inside, but it is still there. Okay, so now what are the zeros that are going to go with this? The zeros that are going to go with this are going to be x equals 0, corresponding to the 3x. Notice 0 times 3 is still 0. 2, x equals 2, right? 2 minus 2 is going to go to 0. And x equals 3. That's our other 0. Okay, now what about our multiplicity? It's pretty easy, nothing fancy here. They all have a degree of 1, so it's all a multiplicity of 1. Okay, right? 2 down. Now, what about the end behavior? All right, let's go ahead and look at the end behavior. Again, we want to plug in infinity or negative infinity. Well, actually, sorry, not or, both. You want to use both to see what it looks like. Okay, so our end behavior, we're going to plug in f of infinity, which equals 3 times infinity cubed. Again, we are only looking at the 3x cubed because it's the largest term. It's going to have the biggest effect when we go to very large numbers. So there is other things that we would need to plug infinity into x for, but we're not writing it because we don't care about it. It's not going to matter. And likewise, let's go ahead and set up the negative infinity while we're here. So we have f of negative infinity, which is 3 times negative infinity cubed. Alright, so infinity cubed is just infinity. 3 times infinity, well, that's still infinity. So that's equal to infinity. Negative infinity cubed, if you remember, that is equal to negative infinity. 3 times negative infinity will be equal to negative infinity. Nothing changed about it. So when we go to the right, we are going up. When we go to the left, we are going down. Not too complicated. Let's go ahead and draw it. So we're going to have zeros at 0, 2, and 3. So 0, 2, and 3. And then we have end behavior that as it goes to the right, it's going up. So this one's going up. As it goes to the left, it is going down. So this one is going to be going down. And then what's happening in between? Well, we have all multiplicities of 1. So we're just going to connect them with straight lines that are just going through the points, something like that. Beautiful. That is our graph. That is a great representation of it. And that allows us to do many analyses of it, right? You may have a boss who needs a graph and needs to know what it looks like, or you may need to find out what this graph looks like on the fly, right? This is a great way to do so. And last but not least, we have 75, which is going to be f of x equals negative 5x squared minus x cubed. And there's a great little twist in this one. Very good little twist, right? Especially when we get to the end behavior. So we're not going to think about it too much for right now. Let's just go ahead and work this out, and we'll see that twist as we get to it. So we're going to want to go ahead and factor out our greatest common factor. Right? That's the first kind of factoring we can do. What is our greatest common factor? Well, you might be inclined to say that we should factor out a 5. But notice this doesn't have a 5, so we can't factor out a 5. What can we factor out? Well, this has a negative, and so does this one, so we can factor out a negative. And they also both have x's. Actually, x squared is our highest power in both of them, so we can factor out x squared. So that leaves us with 5 plus x. It's weird to write it that way, right? You probably don't usually see it like that. If it makes you feel more comfortable, you can change it. But notice it's still the same equation. Okay? So just like that, we are all factored, we're good to go. And so now our zeros are going to be, well, just x equals 0 for this one, and x equals -5 for this one. Right, those are our two zeros. Now the multiplicity, we have to be careful. What is our multiplicity here? Well, we have 2 on our x, right? So that's going to have a multiplicity of 2. And then on this, x plus 5, we have a multiplicity of 1, just because it's a power of 1, so that has a multiplicity of 1. Now our end behavior, and this is where we have to be a little bit careful. Remember, when we're figuring out end behavior, we look for the highest power. The highest power is going to have the biggest effect at very large numbers. So, what's that going to be? Well, it's not x squared, it's going to be x cubed. And why is that a twist? Because we usually write the highest power first. And they may try and mess with you. They may do something like this, but don't let it fool you. X cubed is our highest power, and we want to go ahead and look at that. And actually, negative x cubed. So, we're going to look at f of infinity of negative infinity cubed, right? Because it's just that x cubed term right there. We do got to keep the negative. The negative is on it, so we do need to keep it there. And f of negative infinity, which equals negative of negative infinity cubed. Right? Infinity cubed, well, that's just going to be infinity, and then we have a negative on the outside that we have to tack on, and so that's going to be negative infinity. What's negative infinity cubed? Well, that's just going to be negative infinity, but then we still have that negative outside, which is going to turn it positive. So this will be equal to infinity. Now, what does this say? This says as we go to the right, it's a little bit different. It goes downwards. As we go to the left, it goes upwards. Okay, so let's go ahead and sketch this out. So our zeros are going to be 0 and -5, so we have a 0 at right there. We have a 0 at -5. Now we want to go ahead and draw our end behavior. So as we go to the right, it's going down, something like that. And then as we go to the left, it's going up, like that. Alright, now what's happening in between? We want to look at our multiplicities. A multiplicity at our 0 of 0 is going to mean there should be like a little parabola right there. Multiplicity of 1 at our 0 of -5, well, there's a straight line through it, and so it's actually just going to look something kind of like this. Just like that, we'll connect it, and there's our graph. Okay, notice how this one is a little bit reversed from something like this, or a little bit reversed from something like this, right? And that's going to be all due to that negative inside in front of our highest power, x cubed. Okay? There you go. Good luck. I can't wait to see you guys. Bye.